Chapter 3, Section 2.4, Part 1 video. In this section, you'll be looking at some different scenarios of linear stuff and modeling. The two graphs given, which graph best illustrates your pulse rate during an aerobics class? If you can think about a warm-up and doing aerobics and then a cool-down period, then this best illustrates it. Here's your warm-up, working out, cooling down. So B would be your best answer. Alright, the number of senators present versus the number absent in the U.S. Senate. Okay, that's 1, that's 3, that's 2, and that's 4. Now I'll explain it. It's going to be linear for the first one because you're looking at how many are there compared to how many are absent. So the simple interest earned at a given interest rate investment, 3. Okay. The time it takes to travel a fixed distance, would be 2, and then the volume would be 4. So I still may go back and scratch this one, but that's the answers. Okay, I wanted you to see these because even I was kind of like, okay, what are they trying to get to on these problems? And so the modeling portion of it really is a little bit ambiguous, but the volume of a hot air balloon as a function of its radius can be modeled by a basic function. Well, volume is cube, right? Cubic. So the word they're wanting is cubed. All right. The time it takes you to travel 600 miles as a function of your average speed can be modeled by the transformation of a basic function. And that would be the time it takes to travel 600 miles as a function of your average speed would be the reciprocal. There's no way on God's green earth I would have got that. I would have put linear. But so there, that's why I'm giving you the answers on these. The width of a square skylight as a function of its area can be modeled by the transformation of a basic function. Well, if you're the width of it, of a square skylight, is a function of it's a square root, would be the inverse of it. That I can see a little bit more. Alright, so suppose that the function y equals fx has the following tables of values. Is the function increasing or decreasing? So could the function be concave up, concave down, or linear? So I'm going to show you this, and I guess the easiest way to do this would be just to show you how to do it on the calculator. So, alright, well, that's coming up. Let's take a picture of the problem. Alright, so let's look at this. Alright, so we're going to use L1, L2. Okay, so I'm going to go second plus number 4 to clear all your list. Right, we're not going to do a regression. We're going to do what's called a stat plot. Okay, which is pretty cool. And it's a way to graph any set of order pairs to kind of see what they look like. So I'm going to enter them just like I did on a regression. So going 0, enter, 1, enter, 2, enter, 3, enter, 4, enter, enter, 4.5, enter, 2.25, enter, 3.375, enter, and then let's see, 5.0625. Enter. Alright, so make sure all of your numbers are correct. The last one, the 5.0625, rounded by, and then they'll put that in, it rounded up to 5.063. Now I got all that in, and what I want to do is I want to clear so you can kind of see. I'm going to go second y equals. Okay, what I'm going to do is I'm going to turn my stat plots on, and so you hit enter, and you're going to arrow over. Well, you want to arrow over, make sure it's on the on, and hit enter. Okay. The first one is just dots. The second one is dots in a line. The third one, fourth, fifth, sixth, don't worry about. So I like doing the first one. It's just a little bit easier to see. X and Y are coming from L1, L2. All right, now let me. Okay, I got them on. So let me hop out. Let me make sure there's nothing in my Y1. Can't anything be in the equation after. Okay, so make sure that's. I'm gonna hit graph. Okay, so it makes it look like that. But here's a really cool thing. If I hit zoom, see that number 9? It says zoom stat. If you hit that, what that does is it makes it. It sets the X parameters and the Y parameters on your window, and you can see it pretty cool. So if you look at this, it doesn't appear to be linear. It does appear to be concave up, right? So, and 2, is it increasing or decreasing? Well, as X goes right, the function goes up, so it's increasing. So that would be increasing. Concave up, concave down. So concave up would look like this, concave down would look like that, and linear would look like either that or that. So it is concave up. Okay, check that. Yeah, there you go. All right, so this concludes section 2.4, part 1, chapter 3's section 2.4, part 1's video. Oh, before I go, whenever you turn your stat plots on, when you get done using them, go ahead and turn them off, and that would be second y equals, and if you'll hit number 4, enter, it turns them back off, and you won't have any kind of issues when you're going to graph anything else. If you forget to do that, you're going to get what's called a domain error, or an error when you go to plot, and that's why. So just as soon as you turn them on, when you get done, make sure you turn them off, okay? Keep you from having a really hard time with some problems.